Hello everyone, welcome for the last session of today. I hope that we're going to have a good session. I'm going to have a couple of questions. I would like to make it interactive. So if you had your coffee, if you had your desserts, so let's start. I'm going to talk about peaceful Django migrations. My name is Efe, not Efe. It's pronounced as Efe. It's a Turkish name. I'm originally from Turkey. I'm living in Netherlands for a year and a half. So in the past, I worked as a founding engineer in early phase startups, and I have experience with Django. I'm working with Django around 10 years. Now I'm working as a senior engineer at SendCloud. SendCloud is a shipping company, operates in Europe. I have a lovely blog, which I rarely write. It's at efe.me. I also shared the slides of the presentation in this URL, so you don't need to take any pictures, you can just go there, check any links and references. Just please focus on the content. And I also try to be active in the Django community. We try to have a community in Netherlands for Django, which is Django NL. We've celebrated 20th birthday of Django. I also had a chance to be a mentor at Django Girls Amsterdam. And before that, when I was living in Turkey, I was also trying to be active in PyCon Turkey and PyIstanbul community. I love talking about Django, Python, recent LLMs, or backend. So if you'd like to talk with me anything about these 4 items, I would be happy. And I'm also fan of boring technology. So if you would like to talk about recent Python packaging, I'm not very interested. But if you'd like to talk about PostgreSQL internals or how we can optimize these known technologies, I would be happy. So please share with me your best tricks. Okay, these are the pictures of me. This is me and my co-founder from 20 years ago. And I like playing backgammon. I occasionally run. I would like to run also in Chicago Marathon one day. And let's come back to our topic. Enough for my history. And in our agenda today, we have 4 items. The first one is Django Migration 101. I wanted to have this talk as a beginner friendly. So if you are a complete beginner to Django, you gotta also learn some stuff about Django migrations from the first chapter. Then we're gonna, in the second chapter, we're gonna deep dive to what is this downtime thing? Why we have downtimes when we are having a deployments? And the third one is more PostgreSQL specific problems, which are logs. What are the things which causes these logs and makes a downtime in our deployments? And in the fourth item, we're gonna talk about how can we predict before they happen. And if we have time, we're gonna have a Q&A at the end. So what I like textbook definitions. So I would like to start with another textbook definition. What is Django migrations? Django migrations a way of tracking and applying changes to your database schema so it stays in sync with your models. But also what's not about? It's not about migrating from PHP to Python Django. It's not about migrating from API v2 to API v3. It's not about migrating Django 4 to Django 5. It's not about migrating REST API to Django. Also, it's not about migrating from another PostgreSQL version to another PostgreSQL version. And I am also example-oriented person. So I'm going to start with an example, which is a library. It's not a framework or software library. It's literal library which has books. And imagine that we have a library. We would like to keep the records of the books. What are we going to keep? We're going to have a book entity. And if you like to have a book entity, it's going to be something like this in Django world. We're going to have the title, author, genre, and we would like to list the books for people who are a member of the library. And after we define our model, we're going to run this lovely management command. In Django, management commands are things which followed by Django Python manage by. And the first one is make migrations. What is make migrations? Which basically a management command turns the Django models to Django migration files, which are going to be run in the database. And when we run make migrations, this is the example output. It says that, okay, I created a new migration file for you. And it also summarizes what is inside of the migration, which is create model book. And if you take a look at the migration file itself, you're gonna see this. And in here, it inherits from the migration class. There is a special flag for the first migration in each app, which is initial true. Since it's the first migration, there is no dependency. So dependencies are empty. And in here, you're gonna see operations. And as you can see, these are also Python classes and models. Okay, you might ask me, oh, Efe, you said that we're gonna create a file to run on the database, but we are using PostgreSQL. How PostgreSQL can understand any Python? Okay, let's go one step more. So there is another management command in the Django, which is actually creates the equivalence of migration file, which is SQL migrate. As you can see, I passed the books, which is the example app name, and the migration number in here. And it outputs the SQL code, which actually corresponding to my migration file. And actually, when we run our migrations, this code is going to be run in the PostgreSQL or any database, not the Python code. Then we're going to say Python managed by migrate. It is going to apply the migration in the database. And you're going to see that, okay, it's applied. Good. Okay, so as a nature of every project, requirements are changing. And we had a simple prototype which only had title, genre, and author. Now we would like to also add ability to list by languages. How are we going to do that? We don't have this information. So we need to add a new model, which is a language. It's going to be a char field, max length. But how are we going to do this in the database? I just updated my Python models. Then I'm going to run my migrations again, and it's going to understand the difference. What's the different state of my current database, and what's the last item I have in my migration files. And it noticed that, yes, I need to add a language field to the model. And this is the inside of the content of the second migration file. As you can see, it says add field, model name book, language. And if you take a look at the SQL migrate, this is the output as we guess. What it does, it alters the table of book, adds a column. This is the default value. Then we run again migrate because we need to apply this migration to a database. If we don't do that, it's going to stay in our Python and it's not going to change anything in the database. But how does Django know to apply only the second migration in this? Do you have any guess about it? It can be, you can be loud. It's not a one-way thing. Yeah. Yes, so good. Actually, Django is super smart, and they have Django has a default database table which is called Django Migrations, and this is the structure of the Django table, which has ID, app, name, and applied. ID is basically auto increment ID. We don't use it that much. App is app name, which is books in this example. Name is the name of the migration file, and applied when we apply the migration. And if I do this in my application, I'm going to see this response from the PostgreSQL. As you can see, 18 and 19 ones are my own migrations, and these are the times, these are the names. So good. But of course, running a raw SQL is not that Pythonic or Django-esque. So there is a good management command which we can run, which is Python managed by show migrations. It also shows you that if you apply the migration, you're going to see X next to it, and you're going to see the whole migration tree of your application. I also like to compare Django with Rails. Rails, another web framework which written in Ruby language. And I was curious, how do they do? Of course, they also have a migration management system. And I think I like the Django way more. Basically, Rails also has a same database table, but they only keep the ID of the migration, which is a some kind of Unix timestamp, and they don't know anything about app name, other stuff. I think Django's way is very well fit with the Python's philosophy, which is explicit is better than implicit. Also, it is possible to revert migration. Imagine that we say that, okay, language, we don't like to add language anymore. We would like to revert it. So you can also give app name and migration order, and it's going to revert the migration, as you can see. So, as a wrap-up, I would like to list the terminology of Django migrations. Django models describe the structure of the data we keep, like title, author, for books. And Django migration files acts like a to-do list for the database, what needs to be created, updated, or removed, like add language, remove language, these type of examples. And I would like to also create a cheat sheet for Django migration management commands. The first one is make migrations after updating each models by, show migrations to see what we applied in our database, migrate to run the migrations on PostgreSQL, and SQL migrate for previewing the equivalent SQL code of the migration file. So I would like to make a small quiz because it should be interactive. So as you can see, I run same command in 2 different times, but the output is different. In the first one, it only says alter table, and commit. And the other one creates table, insert info, drop table, and alter table. What can be the reason of this? Any guesses? I'm going to check my time. Oh, okay, we are on time. Yes, please. Yes, but the opposite. Actually, the first one is PostgreSQL, and the second one is SQLite. You were right. So actually, we have same migration files, but the capabilities of the databases might differ. In SQLite, it's not possible to alter the table. So therefore, it drops the table, adds a new field, creates a new table, and exchanges the data. So this is the internals. But I think it's a nice fun fact to know. So when you are running a migration, it's also nice to keep in our head. So we onboarded what are the Django migrations. Now we have idea what are the basics and principles of the migrations. So let's move on to the next topic. So I would also like to do some emotion test. I'm going to list a couple of words to you, and you're going to say, what do you feel like? Do you feel happy? Do you feel sad? Downtime. Incident. Uptime. Outage. Availability. 500. This is just a number, but I don't know. We have some kind of negativity. And yes, so now, today, we're going to rewrite our emotions towards these words, and we're going to understand what's happening actually. So again, textbook definition. What is downtime? Any period where end users cannot successfully complete their intended behavior. It can be, they might click a button, they might do some other actions, but somehow it doesn't work. Maybe it works very slowly, it doesn't work. Anything which affects the end user. And I thought about it, like I would like to summarize this topic very well. And I thought, okay, what are the real reasons of these things? And I come up with these 2 reasons. Maybe there are more, but this is my summary. If you have more, please share with me. And the first one is schema version mismatch in rolling deployment. It's a fancy term, but I'm going to explain. The second one is a lock-in migration that takes a long time. Let's deep dive. So this is an example chart for modern applications, how we deploy apps. In the modern applications, we usually have one load balancer or a few of them, and we have not thousands, but lots of apps. And we would like to update the version of these apps without affecting any users. Then how do we do that? So the left one is the first, and the right one is the last. So imagine that we have 2 V1, the first version, and we would like to deploy the second version of it. What we do, we add the second version, we add another one, and we kill these old versions, and therefore, all users actually request to the new versions. This is a basic rolling deployment. You might also say it canary deployment, Boolean deployment. The principle is the same. We are adding more resources, removing old resources, and somehow it should work. Also, there is most of time we have this. We only have limited databases, one database, and lots of app servers because our database is most of the time a single resource of truth. So therefore, it's very hard to replicate it. But on the other side, we can run lots of applications. They're going to handle different requests. So this is also another diagram. We have one database, multiple app servers. Okay. Imagine that we are doing a deployment, how it works. The first step is that Python manage by migrate. First, we are deploying any, before we are changing any code in any app, we need to update our schemas. So what we do, we call Python manage by migrate. We already created our migration files, committed to the Git. Then in the continuous deployment, we pull these migration files and we are running them on the servers. The migration adds the language column to book. But while the deployment is in process, not all app instances are updated yet. So we only added this field in the first application, but the rest of them, they don't know yet. And all old app instances with old schema, they might still create new book instances without setting the language. But I already said that I need this information in my database. How am I going to do that? If the column is already not null, those inserts will fail. In our example, they are not nullable. If it's nullable, they might insert rows with null values. It's so good. But the new app doesn't expect this. Maybe they would like to do something different. And the new app instances, they expect every book to have a language. Imagine that I also change my Python logic, and if I have a serializer, I don't expect them to be null in the front end, in the API. But they might read rows created by old instances which have null values. And this might also cause us a problem. And this is basically a window, mismatch window. During this rollout, there is a period where some application instances speak the old schema contract and others speak with the new contract. This creates a temporary incompatibility between application and database. And this is the first reason of downtimes in our deployments. And this is the summary of what we have. What about the second one? A migration that takes a long time. So let's see the brief steps of our deployment. The first step is we are detaching from the load balancer. We are saying Python manage by migrate, but it takes 300 seconds. Why? Then we're going to deploy the first step, but we are not in that step yet, and it takes so much time. And people are complaining. It doesn't work right now for end users. What's the reason? Because apps cannot read or write to the database table. Why? We're going to see it. So these are the main two reasons. The first one is rolling deployment have different schemas in first step and last steps. And the second one, we have a migration which takes so much time, but it somehow logs the other processes. So let's learn about the schema changes that causes logs. This is a super nice website. Don't look at the design, but content is the king. And this is pglogs.org. I love it. This is a website of Hussein Nasser. He is also a very nice developer who has quite nice content about Django, PostgreSQL. I really suggest it. And in this website, you can see the internals of PostgreSQL logs and how they work. Basically, I would like to onboard you a bit. So in PostgreSQL, there are two types of logs, which are in the main categories, table logs and row logs. And their names are not that intuitive, in my opinion, like access shared log, row share log, share log. They are a bit weird. I would admit that. Then there are comments. And you can see that if I do a select, what type of logs I'm going to acquire from the database. And what type of SQL comments are going to conflict with this log. If you see this as a list of items, I couldn't understand very well. So therefore, I wanted to create a graph of this information. So when you are making a select request, when you would like to read something from the database, actually it creates an access share log. And access share log conflicts with these SQL statements, comments. But I don't know, there are 27 of them. I cannot memorize them from my mind, like, so I'm not that smart. And I created the main graph of it. I'm sure you cannot see it, but if you see it, you are not gonna also, it's not gonna be that easy. I would like to share this as some kind of interactive thing for training purposes after the call. And if you'd like to deep dive into the table logs of PostgreSQL, Gülçin wrote a super nice article. I really suggest this. I'm not gonna go super details of the PostgreSQL details, but please, so good. Okay, we know that SQL comments can conflict with each other, but how can we predict that? Of course, I love interactivity. I'm gonna ask you a couple of true-false questions. The first one, adding a nullable field creates a long log. Is it true or false? It's a nullable, a new field. What do you say? False. Correct, you won. The second one, adding an index creates long log. Is it adding an index creates a long log or not? False. I see some false, some true. It's actually like this. It's true if you create index, and it's false if you create index concurrently. And as default, Django creates index without concurrency. And if you have a super big table, and if you like to have some kind of data consistency which adding an index, PostgreSQL needs to wait to finish it. So therefore, please add your indexes concurrently. I also don't know why we don't have this flag in Django settings. I would like to also have a setting like this in Django. If we have it true, it's going to automatically use Django index concurrently. And the third one, another question. Adding a non-nullable field with default value creates a long log or not? True? Who says true? Who says false? We are half divided. Yes, this is nice. I like this. So who are these two people? Any guesses? They are great people. I really admire them. And you are reading right now PostgreSQL 11 release notes. And it says that in here, allow alter table to add a column with a non-null default without, I'm so bad at writing, I know, I'm sorry. These two people were Andrew and Serge. They added a new functionality in PostgreSQL 11. And this is the commit. I tried to read the code. I don't know anything C, but it's so nice to see they're super smart. And if you are using, bottom line story, if you are using PostgreSQL 10, it creates a log. And if you are using PostgreSQL 11 and above, it's not going to create any long log. But there is a trick. If the default value is constant, so if you say that default value is Turkish in the string, it's not gonna. But if you have some kind of now function which actually calculates the time, or if you have some kind of function which gets a random UID function, it's also gonna create a log. This is a huge mental load for a developer. We cannot know all of them. So, and this is so, it makes me paranoid. Like, was it like this? Which Postgres version do we have? What about, is it a default constant? What about dynamic one? I don't know. I need to try, I need to see, and it makes me mad. And this is one of my friend Yiğit Güler. He's my first mentor in Django world. He is a sailor. I really like working with people coming from different backgrounds rather than just full software people. And because they bring some knowledge from their past principle. And since he's a sailor, he has lots of principles about sailing, sea safety. And he is also addictive of aircraft investigation. He loves watching this type of post-mortems of planes. And we had this philosophy in our team, sleeping in the storm. So if we have this type of mental load in our applications, in our head, we cannot sleep in the storm. So therefore, we need to automate this type of checks. And they cannot be a checklist because we cannot create these items one by one. We are going to miss a couple of them. And if you like to deploy something in our stressful time, are we going to have focus to read all of the checklist items? I think we should learn from the aircraft investigation. So according to statistics, because you're not going to believe me, I'm going to throw statistics to you. Airplane burning systems have cut crashes by 85% since 1970s. And it saves huge amount of money because we actually prevents the mistakes before they happens. We don't need to deal with after the accident. So we should sleep in the storm without having a mental load. So therefore, I'm going to introduce you a couple of automation tools to predict the logs without guessing, like, is it true, is it false? The first one is Django Migration Linter. It's a great package. Actually, I was planning to write similar package to this, and I saw that it's already exists, and I felt so happy. It's so nice. It's a native Django package, which you can use from tomorrow. What you need to do, you just need to install, I don't know, I'm boring guy, I'm using still pip. Pip install Django Migration Linter, and it introduces you a new management command, which is a Django way. You can just run Python managed by lint migrations, and it's gonna make analysis over your migration files, and it's gonna say that, okay, this is suspicious. Please take a deep look on this. Maybe you need to change a way to do it. And the second alternative from GoLand, which is a Squawk, it's so hard to spell, and you can install it with the npm. It's a bit similar also. It is more like linter-based. There are rules you can disable and enable. Basically, you can pipe SQL migrate to Squawk, and it's going to give you analysis like this. Of course, this is not the Django way. I created a small snippet for it, and you can just run Python managed by Squawk migrations, and it's going to just give output. And it's going to only give this output for unapplied migration. So it's a very nice thing to plug your CI/CD tests. Before deploying anything, you can just have this output, and you can have a control on your deployments, and you don't need to be a paranoid what's going to happen. And you can also find the management command from this URL, tinyurl.com/squash-migrations. And the third one is a bit controversial, but it's also nice to mention. It's a quite edge technology, which is called PGRoll. It uses internals of the PostgreSQL. It creates the temporary shadow columns and views during the migrations, allowing both old and new migrations can work at the same time. I'm going to briefly explain it, but I would say that I'm not sure that it's a production-grade ready system. It also doesn't have full integration with Django, but it's worth to look eye on it. Basically, before starting, you need to init this. It's going to create some database models in the PostgreSQL, which with this command pgroll init. Then you need to have these settings. And as you can see, we need to set options in here. And we need to add a search path. And this search path actually coming from the environment variable. We need this during the deployment. And I'm going to briefly explain the deployment with pgroll. First, we need to, so pgroll doesn't work with the Django migrations. We are actually using Django migrations as some kind of semi-source of truth, but we are going to create pgroll migrations from Django migrations. And we are going to get SQL equivalent of migration, and we're going to bypass it to the pgroll, and it's going to create a new file, JSON file for us. Then we're going to, in the beginning of our migration, we're going to say, okay, we are ready. pgroll, start our deployment. And it's going to create a new schema for us, actually. And in this new schema, we're going to have our new field. So then we're going to set our environment variable. And we're going to say that, okay, in this app, we're going to use this schema. So therefore, get it from the environment variable. After the migration of first application, we're going to do it in the second one. Then each application is going to be deployed. Then we're going to fall back to default one. Okay, now everything is settled. We're going to have the public schema back for all applications. Then we're going to say that, okay, this is completed. I think this is a nice technology. I haven't used it before. This is a disclaimer, but it looks nice. And if you look to diagrams, you can see that this is a time. We have old version available until the schema changes are completed. And this is an example of how they map the fields under the hood. Okay, how we can predict the logs? The first one is Django way. Django migration linters, install the package, have new management commands, run in your CI/CD pipeline. I'm gonna share the slides, by the way. You're gonna have it. The second one is Squawk. It's a Go package. It's more like a linter way. You can disable, enable rules. It also works. And the third one is PG rule. It's an alternative to Django migrations. And this is the end for my talk. If you have any questions, I'm happy to answer them if we have time.
Thanks very much, Efe. Efe, excuse me. Any questions? Yes.
Can you go back into the details of the last slide you showed? Sorry, the second to last. Third last? Fourth? This one, yeah.
Yes.
So is this like tenants with deployments? Like your migrations are in the tenant schemas?
What is tenant schemas? I don't know very well, so therefore if you explain
So when you have public is your
default, yeah.
right? And then you create another schema, right? So you're using that as the deployment?
Exactly.
Okay. So how do you tie the data?
I don't know the internals of it, to be honest. I'm not gonna lie, but it works under the hood. I don't know the real answers, but as far as I know, they are using virtual schemas, and it copies the data on the background. So therefore, you can make this. It's like a view of PostgreSQL. When you have a view, you don't need to create a new table. It actually works virtually. I guess it also works like this. I don't know the internals, but they also have a great blog post. Maybe they explain better how do they do it.
Okay, thank you.
Any other question?
I have one. I've definitely hit the issue before where you add a not nullable field and in a hurry and forget to make the separate steps migration. Did one of the apps that you recommend have a protection for that or some automation for creating those separate migrations that are necessary to add a not nullable fields?
So there are also some other packages one of them is from Yandex. It creates also it's called Django safe migrations, but I would like to have multi-step migrations and manually operate the migration flow more. It's mostly more personal preference, but there are also other ways to do it, to be honest. What do you choose, to be honest? I'm also curious.
I just tried to remember right now.
Yeah.
Okay, thanks. Any other questions? All right, I think that's it. Thank you very much, Efe. Please give him another round of applause.